Students will use tools such as a ruler, protractor, movable XY pegboard, pattern blocks, graphing paper, tracing paper such as patty paper or transparency paper, and computer applications to explore how reflections, translations, and rotations change an object's location without changing the dimensions of the object. Through these tools, students will understand that the resulting image of a reflection, translation, and rotation remains congruent to the pre-image. This is known as a rigid transformation. As students begin working with transformations, using concrete materials will help students see as transformations are performed, the dimensions of the shape does not change. These students are using pattern blocks to perform translations and rotations on a printed coordinate grid. They were asked to record on the whiteboard what they noticed about the shape after each transformation. Okay, and now before you move your transparency paper, I want you to write the length of the bottom base of your trapezoid. Determine what the length of the bottom base of your trapezoid is. And you can write that on the transparency paper too. All right, great. And so now I want you guys to think back to when we were doing the Miss Pac-Man task, and when Miss Pac-Man was sliding from left to right, or she was sliding up and down. What term did we use for that? Who can tell me?
Translation.
Okay, I hear translations from Ilani. David, what did you say?
I said translation.
Translation. Do you agree with that notation? Okay. All right, so now I want you to translate your shape down 5 units. Translate it down 5 units. Talk to your elbow partner or the people at your table about what did you notice that changed about the shape? What changed about the shape? Go ahead and discuss that.
Nothing. It's just, the position that's in.
I don't think it changed because all it did was just go down.
Yeah, I feel the same way.
When you look at the length of your base again in your image, so from the pre-image to the image, the length of your base, is it still the same or did that also change?
It's still the same.
And how do you know?
Because the width of it is still the same.
Talk to the people at your table about how your shape has changed.
So it flipped in a way. It changed positions again, but this time it flipped like upside down.
So question to the table, is flipping and rotating the same?
Yes.
Yeah.
You all think that it's the same? So think about Miss Pac-Man. When she flipped, remember her mouth was facing in a different direction? Was that the same as her turning north, south, east, and west?
Oh, yeah.
No.
If you're rotating around the origin, I would hold my finger there. And then
Oh, to the left.
turn my shape, to the right. Does that make sense?
Mm-hmm.
All right. So did the length of the base change?
No.
It
Yes.
stays the same? Anthony,
Yes.
you said yes? Count it and see, Anthony. Is it still 8? It's still 8? All right, great. So far we've noticed that when we translate it, nothing about the length of the shape changes. When we rotate it, nothing about the length of the shape changes. Based on that information, when we reflect it, do you think the length of the base is going to change?
No,
No.
Why not?
because it stays the same. It just goes in a different position.
When working with or developing activities to address this standard, be sure to include shapes which vertices are in more than one quadrant, as well as shapes that are not located in quadrant 1. Once students have had time to develop their understanding of these rigid transformations and their properties using concrete materials in illustrations or drawings, they are ready to move on to the abstract phase of the concrete representational abstract model.
B is A is reflecting off over the x-axis to B. So
So we need an x-axis card. This one.
yeah. Everything on here, right? Where's A?
This one. Oh, here's A. And there's also Y.
These students are working on the collaborative portion of the Representing and Combining Transformations FAL, or Formative Assessment lesson, found in Unit 1 of the 8th grade Georgia Frameworks.
Where's C? C is a rotation.
Where's Oh, there it is.
Rotates from B. I think it's rotating because it starts from here and then it ends up over here. So the only thing that I think
How much degrees do you think it rotates?
90 degrees.
I think it rotates 180. Because 90
Plus
90 is 180.
Okay.
So,
With this formative assessment, students could record their thinking on a Post-it note and stick it to the door as they leave the classroom. A question such as this could provide feedback as to students' understanding of rigid transformations using non-traditional objects. It could also provide feedback about students' understanding of vocabulary terms such as x-axis, y-axis, reflection, rotation, parallel, and perpendicular. This is a great tool to help guide the next day's instruction and/or develop small groups of students to pool to remediate any misunderstanding. With this formative assessment, students are asked multiple choice questions about congruent figures after transformations are performed. Plickers is a free program which allows immediate feedback for students and simple data collection for teachers. Students hold up cards containing special barcodes which can be scanned using any mobile device. For more information, please visit plickers.com.